Hey class, I'm not here today, but you can still go through these guided notes on your own or as a group with some other people. I will expect you to complete page 81 notes in your book, which is what you're looking at right here, and I will check those on Monday. You have to have them done, so you need to actually watch this and fill it out with me. If at any point I start writing too quickly and you don't have time to write it down, pause your video, write stuff down, and then come back to it. I expect all of that I'm going to go through today to be done when I check it. So we are talking about the triangle angle sum. So we're still talking angles, but now specifically, it's angles in a triangle. What happens in a triangle is when you would take angle A plus angle B plus angle C, you're always going to get the same number. No matter what those would be, if it's going to be a triangle, it has to add up to 180 degrees. Now, I'm assuming that might have been something you were told back in, I don't know, middle school at some point, but you probably forgot about it. So we're going to go back through and do examples of how this turns out to be true. So for example 1, it's not just here's one triangle, find me a bunch of angles. We got a couple things going on here. So we have this little skinny triangle on the left. We have the mediumer triangle on the right. Mediumer is a word. And then we got this big old triangle that goes from point C to A to B. We need to consider all of these because there's more than one way to do this. First one I'm going to look at is triangle CDB. Now CDB has angle B in it. It has a 70 degree in it, and it has this box, which remember means 90 degrees. What I'm going to do, you don't have to write the equation for this, but this is how I'm explaining it. I'm going to add my three angles together because it's in a triangle, and triangles add to 180 degrees. Then I'm going to add the angles that I can. I knew 90 and 70, and when you add 90 and 70, you get 160. And when I subtract 160 from 180, you get 20 degrees. If you can do that in your head without the equation, it is not 100% necessary, but you're still thinking the same thing. You're thinking, add the angles we know, subtract it from 180, you'll get 20. I still have to go find A and C. I'm going to start by finding C. You don't have to do it this way, but this is the way I'm going to choose to do it. C is this skinny little acute angle in here, and it's not equal to 90. 90 is angle ACB. This whole big angle is 90. C is part of the 90. 70 is the other part. Remember the math word for that was that they are complementary. When I would add these two together, I'd get 90, which means that's my equation. When I would add C and 70, I would get 90. So to find angle C, I'm just going to subtract 70 from 90, getting me a 20 degree angle. So this guy is 20. We have more than one way to find angle A. I'm going to have you look at this little triangle. So the one that I just put the 20 degree angle in. So angle C was 20 degrees. Angle A, I don't know what it is, but this one, this is the third angle in the triangle. We would know what it is because we have a straight angle by point D. So if this was 90 degrees on the right, this would be 90 degrees on the left. So these three angles will add up to 90 degrees, meaning A and 20 and 90 will have to sum to 180 degrees. I'm going to add the two that I know, which gets me 110. I'm going to subtract those from 180, sorry about the focusing issues, and I get 70 degrees. So now we found all three angles, only using the fact that triangles add up to 180 degrees. I'm going to do similar things for number 2, only now we've got three letters that we're going to look for. One of them is not just a Z, it's got this whole equation. More than one way to proceed. I'm going to find X first. X does not equal 90, but X is part of the 90. I don't know that it's half. It's not told to me that it bisects, but I do know that the other part of the 90 is over here, and it's 40. 40 and X are complementary. 40 and X add up to 90 degrees. So X is a 50 degree angle. I'm next going to try to find angle Y. To do that, I'm not going to look at the whole picture. Sorry, I'm not going to look at the little picture. I'm going to look at the whole thing. What I'm trying to say is I'm going to look at this triangle. I'm going to ignore the line that's in the middle. So this triangle has a 60 degree angle on the bottom left. It has a Y degree angle on the right. And it has a 90 degree angle at the top. Which means I just said two numbers. And you can add numbers. We got 60 and 90 and Y adding up to 180 because they're in a triangle. So 60 and 90 and Y add up to 180. So I'm going to combine the angles I know. The 150 comes from the 60 and the 90. I'm going to subtract it from 180. Y would have to be a 30 degree angle. So this is 30. There's more than one way to find z. I'm going to change the triangle that I'm looking at. And I'm going to choose to instead look at the triangle that is on the right. This does not have a 90-degree angle in it. It does have a 50 and a 30-degree angle in it. So I'm going to add 50 plus 30 plus the third angle in this triangle is 2z minus 30. And when I add those together, I still get 180 degrees. Combining like terms, those 30s drop out. I'm just going to get 50 plus 2z equals 180. So 2z equals 130, making z 65. So that one definitely took a little more work than the last one, but still, you need to know the angles of a triangle add up to 180 degrees, which means on number 3, when I don't even give you a picture, the angles of a triangle add up to 180 degrees. That's exactly what I'm going to do. Let me try to move this a little. Oh no, I made it worse. There we go. So, if the angles of a triangle are 3x, 5x, and 4x, the angles of a triangle add up to 180 degrees. 3x, that's supposed to be a 5x, and 4x, the angles of my triangle, add up to 180 degrees. So I can add these like terms because they all have an x in them. 3 plus 5 plus 4 is 12. And now, using my division property of equality, I get, I hope, 15. Pretty sure it's 15. But I didn't answer the question. They didn't ask for x, they asked for angle A. And it told us that the measure of angle A is 3x. So if the measure of angle A is 3x, I can get rid of x, because we just found that x is 15. Therefore, the measure of angle A is a 45-degree angle. Number 4 is pretty darn similar to it. The only difference is the type of terms that we're looking at. Instead of saying 3x, 5x, and 4x, it is 3 root x's, and then 5 root x's, and then 4 root x's. But we're still going to find the measure of angle A, and those still were in a triangle. The measures of the angles in a triangle will add up to 180 degrees. So I'm going to take the angles in my triangle, I'm going to add them together, I'm going to set it equal to 180 degrees. Those are still like terms. They're weird like terms, but they're still like terms. So I'm still going to get a coefficient of 12, and my like term was a root x. I have 12 of those root x's. I'm still going to divide by 12, which still gets me 15. And now I'm not done, because the square root of x is 15. To undo a square root, remember we square. So x is actually 225. So when I go to find the measure of angle A, the measure of angle A is 3 root x. Well, we now know that x is 225. The square root, oh, that's annoying, sorry. So the square root of 225 is 15. 3 times 15 is 45. So we technically didn't change the answer that we just got over here. It's just a different equation to get there. The other thing we need to talk about for today is classifying. We need to talk about the types of triangles that we can encounter. Let me make this not good. There we go. So we have scalene, isosceles, and equilateral triangles. This is based off their sides. A scalene triangle has no sides equal. There are no sides congruent, no sides that are the same. So for example, this would be a scalene triangle, because if this was a 3 and this was a 4 and this was a 5, none of those sides are equal. An isosceles triangle has at least 2 sides that are equal. So at least 2 equal sides. If you need to pause this to catch up to the writing, do so. But an isosceles triangle could be something like this, where 2 of my sides are the same. Remember, those tick marks mean that they're the same. If this is a 5 and this is a 5, but this is a 6, that's isosceles. Now, technically it says at least 2, so this next term would also be isosceles. If I made all of those 5s, this is an isosceles triangle, because I got 2 sides that are equal. I have more than that, but I do have 2. So when you do have all 3 of them, we go ahead and say it's equilateral. So 3 congruent sides, 3 equal sides. We'll end up knowing a lot about equilateral triangles. 3 congruent sides. Anytime you have an equilateral triangle, it's also going to be having all the angles the same as well, because you can't have all the sides the same without all the angles. That's actually the vocab word here. A regular triangle is both equilateral, which is the word we're just saying, meaning equal, lateral meaning sides, like your lateral muscles on your back, or a lateral pass in football. It means sides. It's going to be equilateral, and it's going to be equiangular, which means equal angles. So that is a regular triangle. We will end up having regular pentagons, regular hexagons later on in life, but for now, this is all we have for an example of regular. So when we talk about triangles, we can eventually kind of organize them in groups, which I'm going to attempt to do down here. So I have this big bubble, and it's going to represent every triangle in existence. Some triangles that exist will be isosceles. But every triangle that is equilateral, every regular triangle, is a type of isosceles triangle. So if I draw an equilateral triangle, first of all, I just drew a triangle, but I also drew a type of isosceles triangle. But if I draw one that is not equilateral, again, I drew a triangle, but it's not equilateral. And then we'd have some triangles out here that aren't either isosceles or equilateral. So true or false? All triangles are isosceles triangles. Well, that's false, and our reason for that is this triangle is not isosceles triangle. But all isosceles triangles are triangles. Well, if I'm calling it a triangle, it's going to be a triangle. That's a true statement. All equilateral triangles are isosceles triangles. So I just was talking about that. If you're in this bubble, you are in the isosceles triangle bubble. That's also true. You can't see that, but I wrote the word true. All isosceles triangles are equilateral triangles. Is this triangle an equilateral triangle? No, it doesn't have all three sides equal. That's false. Some of them will not be equilateral. Some right triangles are isosceles triangles. So this is saying, if you have a right angle in a triangle, could you have two equal sides? Well, the hypotenuse can't be equal to anything because he's the longest side. But it is possible for the legs to be equal. We saw this anytime we chopped up a square. That's true that some of them will be. Flip it over, we're almost done. The last thing we're going to talk about are parts of an isosceles triangle. Those two sides that are equal are called the legs. Just like the two sides in a right triangle that are perpendicular were called the legs. This is not called the hypotenuse though. This is the base. Base does not mean bottom. In this case, base just means the side that's not equal. Then we're going to talk about the angles as well. The angle that's across from the base, the angle where the legs come together, this angle is called the vertex angle. There's only one vertex angle because there's only one base. So this guy is the vertex angle. The other two angles, the angles that are on each side of the base, well, those are very cleverly named. We call them base angles. So that's base angle. This is a base angle, which will be helpful because there will be times that I'm not going to give you a picture and I still expect you to figure things out about it. So example 6, the measure of one base angle of an isosceles triangle is 23 degrees. I'm going to draw a picture of that, partially because it helps and partially because it tells me to on part A. So I'm drawing an isosceles triangle. I'm making the two sides congruent, but a base angle is 23 degrees. So I'm going to make a base angle 23 degrees. Remember, base angle could be any angle at the edge of the base. The isosceles triangle theorem that's in bold at the top here says if two sides of a triangle are congruent, so if it's isosceles, then the angles opposite those sides are congruent, which means the base angles, which is a fancy way of saying anytime you have an isosceles triangle, this base angle will be the same as this base angle. So if this was labeled as 23, well, this guy is labeled as 23. So super helpful, especially because I want to know the measures of the other two angles. We just found one of them. There's only one other angle that's missing. And angles in a triangle add up to 180 degrees. I'm going to add the angles I know, 23 and 23. I'm going to set it equal to 180 degrees. So when I combine like terms, I'd get 46 plus x equaling 180. And when I subtract from 180, I'd get 134 degrees. So the other two angles in the triangle would have been a 23 degree angle and a 146 degree angle. You have